Area of regular shapes. Remember, area covers. So we're looking at what we're covering up with something to find the area. So carpet covers your floor, grass covers your yard, paint covers your wall. All of those things are incidences where we need to find the area. So to find the area of a rectangle, we multiply the length and the width. To find the area of a square, remember that the width would be the same as the length. So when we do that, instead of length times width, we can put length times length, which is the expanded form for length squared. Now, how can we use this equation for the area of a rectangle? Or sorry, for the area of a triangle. How can we use the area of a rectangle to find the area of a triangle? Pause the video, draw a picture, and think about it. Hopefully, you drew a diagonal line across and realized that if I cut the rectangle in half, I have two triangles. So the area of a triangle will be half the area of the rectangle, where the length would really be the base and the width would really be the height of the triangle. And those are the two sides that cross at a 90-degree angle. The area of a circle, we're going to have to use that button on our calculator that has a pi, and the formula for area is pi r squared. The area of a trapezoid is a little more complex. How do we find the area of the trapezoid? If it was a rectangle, I do the base. If I created this rectangle, I would have the base, which in this case would be A, times the height. If I'm just looking at a triangle, like right here, I've got base times the height, but I don't have the base. I've used Pythagorean theorem in the past to help me find base, but I don't know this side length here, so I can't use Pythagorean theorem. So the rectangle area is easiest to find the area of. It's the area of the base times the height, or AH. The area of the two triangles is also easily seen. If I look at it, if I look here, the height we said was H. Now the distance here to here is really A. So when I look at these two little pieces here, it's whatever's left over, which is B minus A, divided by 2. So my base of my triangle is B minus A over 2, multiplied by the height, and then I have to divide that by 2. Now when I write it like that, it gets kind of cluttered. So I prefer to take this 2 and write it like this, as divide by 2, which is the same thing as multiply by a half. So the area of that triangle is B minus A over 4 multiplied by H, which is also kind of cluttered and messy too. So when we work with that, we can add the three shapes together to find the total area, because we're just adding pieces of what we're covering up together. So the area of the rectangle is AH, and each triangle has that area. Now I have two triangles with the exact same area, and when we add something multiple times, the shortcut is multiplication. So I added it twice, so I just multiplied that by 2. And the 2 and the 4 can reduce, so we're left with H times B minus A over 2. Now, in order to add them together, we need to find a common denominator. Obviously, my common denominator is going to be a 2. And this had a 1, so I can multiply the bottom by 2 to get a common denominator, and the top by 2. So now I have 2AH over 2 plus H times B minus A. And we can distribute the H into both terms. So we get HB minus HA. And now we have AH plus HB, because 2AH and minus HA are like terms. Remember, there's a 1 in front here, so 2 take away 1 is 1, so I'm left with AH plus HB. Now, if I look at both of them, they both have an H in common. So there was an H that was just, or we could think about it as an H having been distributed into both of them. So we can put the H in front, And that would be the same as h times a plus b. Because if we stop distributing the h or take it out in front, we would have been left with the a and the b. Okay, and that's actually called common factoring. So now we know the area of a trapezoid is h times a plus b. Now that was a lot of work to get to that formula, and you can take a deep breath because in grade 9 applied math, I'm not going to ask you to memorize that formula. But I think it is important to know where it comes from. Now, how do we find the area? We're going to practice and do a few examples. Now, to find the area of a triangle, we always use the formula a equals base times height over 2. And we always look for this right angle because the two sides that create the right angle are obviously the two sides we're going to use for the base and the height. Because remember, in your rectangle, your length and width crossed at a 90-degree angle. So 3 times 4 over 2. BEDMAS tells me do the top first. I get 12 over 2, and it's 6. And remember, we had centimeters times centimeters. So if we think about that as expanded form, we have to write that as centimeters squared. Now we have a circle. The circle is a little more complex because we have area equals pi r squared. We weren't given r, we're given the distance across through the center of the circle, which is the diameter. Remember, diameter is the radius times 2. So if we want to find the radius, we have to take the diameter and divide it by 2. So the radius is 5 millimeters, and we can substitute this into our calculator. And again, we have to use that lovely pi button. BEDMAS tells me do exponents first, so 5 squared is 2. Or sorry, 5 squared is 2. What am I saying? 5 squared is 25. And then I have to multiply by the pi button. And notice I've got a dot above my equal sign because I've got all these rounded numbers. And the number pi continues on forever. I'm rounding to the nearest hundredth. So I've underlined my 3 in my hundredths column. I circle my 9. 9 is bigger than 5, so I need to round up. And again, I need to include centimeters squared as my unit. Now, if you have some free time and you can find a computer that has the program Understanding Math on it, you can often find this on the computers in the library or in Contact. You can go and work on these sections of Understanding Math to give you some extra practice on perimeter and area.